Absolute value inequalities, last topic in Unit 1. So this goes with, it's very similar to the stuff it kind of combines the last two sections, absolute value equations and inequalities. So if we are going to graph this case 1 up here, the absolute value of x is greater than or equal to 7, what's that going to look like? Think about that for a second. What's that going to look like? Absolute value of x is greater. What do you think? Yes, sir. It's going to be two different parts. What's one of them going to look like? Give me one.
One of them's going to be -7 going to the left.
Okay, and the other one's going to be
7 going to the right.
Okay, that's exactly it. Now let's take a look at this. See if we can make sense of that. Great job. Okay, and I got to do something real quick here before I mess this up. Very good thinking. Hang on here. Ooh. That didn't sound good, did it? Yikes. Okay, yes. Why is that? Now think about that. So if we want the absolute value of x to be bigger than or equal to 7, doesn't that mean we need values inside the absolute value that are either really big positive or really big negative numbers? Because the absolute value is going to make those big negative numbers into big positive numbers, right? Does that make sense to everybody? Okay, so this is really important. This is one of the looks we're going to get when we have an absolute value, an isolated absolute value that's greater than a number, then that's the kind of result we're going to get. It's going to look like oars on a boat, right? We've seen that before. We saw that yesterday, right? Yesterday or day before? Day before. Okay. How about this one? What if we have the absolute value of x is less than or equal to 4? Okay, so what's it going to look like? There you go. 2 endpoints and everything in between. It's going to look like that, isn't it? Right? Okay, and how come? Because now we're saying we want the absolute value of x to be smaller than some value. That means that the numbers we're plugging in for x either have to be small and positive or small and negative. So the absolute value makes them small and positive, right? So whenever we have an absolute value, isolated absolute value is less than a number, it looks like a single interval with 2 endpoints. Okay, you see what we're getting at? Okay, so what's all that mean? Well, all that means that absolute value inequalities split into compound regular inequalities, right? We're going to make a trade. Like when we were dealing with absolute value equations, remember what we did when we solved absolute value equations a while ago? We took the absolute value equation and split it into 2 regular equations. We're doing the same thing here. We're splitting absolute value inequalities into 2 regular inequalities in the form of a compound inequality. And we're going to get both types. We're going to get an or inequality and an and inequality, depending on what kind of an absolute value inequality we start with, right? So here's a good way to think about this. Oh, what happened there? My goodness. What happened there? Oh, here we go. Okay. Oops. There we go. So here's one possibility. When the isolated absolute value is less than or equal to something, it splits to an and compound inequality, right? See how that works? So the isolated absolute value is less than a number, it's going to split into an and compound inequality where whatever's inside the absolute value is stuck in the middle and it's pinched between the negative number on the left and the positive number on the right. It's going to look like that. Agreed? Okay. The other possibility is when the isolated absolute value is greater than or equal to something, it splits to an or compound inequality. And here's the pattern. So isolated absolute value greater than a number, whatever's inside the absolute value bars is either going to be greater than the positive or it's going to be less than the negative. Think about why that is. It's going to be extreme. It's going to be extremely big and positive or extremely big and negative, right? Give me 1 to 5. Okay. Okay. So what is our strategy then? Steps to solve absolute value inequalities. It's gonna mirror what we did with equations. We isolate the absolute value expression just like we did with absolute value equations. We're going to create our two cases. They use something here, the KISS method. Keep it, switch, switch. I don't even know what that means. I wouldn't worry about that. I mean, that's not. We don't need to remember that. Just keep it. Just think about these. Think about these pictures. The pictures to me are a better way to remember this. Okay, and we're going to practice that today. We're going to solve both inequalities, which means we're solving the compound inequality, like you guys have been doing now for a couple days. And then finally, you're going to graph your solutions and write your answer in interval notation. Okay, so let's try this. What about one like this? Okay, what are we going to do? Okay, what's part one of our strategy, just like before? Add 1 and divide by 2 because we're isolating the absolute value. All right, so we add 1. So we get 2 times the absolute value is less than 6, right? You told me to divide by 2. That's correct. So those cancel. And look what I get. I get the isolated absolute value. So we get the absolute value of 3x plus 9 is less than 3, right? So there's step 1, isolate. What was step 2? Okay, we got separated into a compound, 2 inequalities, so it's a compound inequality. The question is it the or kind or the and kind? If the isolated absolute value is less than a number, it's and, because we want small values, right? We want small values that are going to be between -3 and +3, right? Does that make sense? If I cover up the absolute value, what are some values that would work in there? 2 would work. -2 would work. 0 would work, right? But -10 would not work. Agreed? +12 would not work. So this is going to split into the absolute value inequality where whatever's inside goes in the middle, and it's going to be greater than what? Well, no, don't try to do too much. -3, right? Whatever's inside is going to get split so it's greater than the negative number and less than +3. Okay? Okay, give me thumbs. Well, but in this case, it's not, there's no equal to on it, right? So greater than or equal to, I mean, like if there's an equal sign there, it works the same way, but we just include an equal sign. Okay? This time there's no equal signs. Okay, so there's step 2. We split. Okay, what's step 3? Okay, but what are we doing for step 3? Solving, right? We're just solving for x. Okay? So what are the 2 steps here to solve for x? Right, subtract 9 and divide by 3. So we'll do that. Subtract 9 and divide by 3. if I subtract 9 from all three parts, because this is the triple inequality for an and. This is kind of nice. We get to do all of it at one time. The 9s cancel, and I end up getting what? I get 3x in the middle. Negative 3 minus 9 is negative 12. 3 minus 9 is negative 6. I don't flip any inequalities, right? Because I haven't multiplied or divided by a negative. So everything stays the same. And you told me last step was divide by 3. Okay, so we'll do that. So those guys cancel. And what do we end up with? X is greater than negative 4 and negative 2. And there it is. Okay, so if we were going to graph that then, what are the two numbers that I need on my number line? I only need 2. Negative 4 and negative 2. And what's that going to look like? Okay, good. It's an and statement, so it's a single interval with 2 endpoints, right? And it's going to look like, whoops, it's going to look like this. Agreed? If I write that using interval notation with comma, what's that going to look like? Super simple. Negative 4 with parenthesis and negative 2 with a parenthesis. Okay? Make sense? Okay, give me thumbs on that. Okay? All right. Okay, how about, let's do this one. Same concept. What am I doing first? Adding 6. It's isolating the absolute value. All I have to do is add 6. And that's going to give me my isolated absolute value is greater than 24, right? So there's step 1. We isolated the absolute value. Okay, what's next step? Split. Okay, so how am I going to split this one? I have an absolute value, and just ignore what's inside. I have an isolated absolute value is greater than a number. Is this going to be an or an and? Or, because it needs to be extreme. I need what's inside to be either bigger than 24, like really big and positive, or really big and negative. Like negative 50 would work, or positive 60 would work, right? But 10 would not work, would it? Okay, so we're going to split this thing up then. So how am I going to write that? What's my or statement going to be? Mason, what am I going to get here? Okay. Negative 3x plus 21 is, no, greater than positive 24. Okay, or, good, what's inside is less than the negative, right? It's either got to be extremely positive or it's got to be extremely negative, right? For an or statement. Agreed? Okay, does that make sense? Okay. And then we just solve both of those, right? And in both cases, all I'm doing is just subtracting 21 and dividing by negative 3, right? So what do we get over here if we do all that stuff? So step 2, let's keep track. Step 2 was split. Now we move on to step 3, which is solve, right? Okay, so if we add 21, what's that give us? Negative 3x is greater than, yikes, 45? Oh, yeah, are we subtracting on that one? Oh, subtracting. Yeah, what am I doing? Subtracting. Subtracting, there we go. Subtracting 21. Okay, which is going to give me, those guys cancel. Negative 3x is greater than 3. Everybody agree? Now what? Divide by negative 3. Ah, good. So I flip the signs, right? So the 3's cancel. And I get x is less than negative 1 for part of it. Okay. Or over here, what are we going to get? We subtract 21. So what's that give me? Negative 45. Good. Negative 3x is less than negative 45 by negative 3, which means good. And so we end up with x is greater than positive 15. So x is less than negative 1 or x is greater than 15. What's this going to look like when I graph it? Is it going to be this or this? Less than negative 1 or greater than 15. Okay, good. An or statement should look like oars on a boat, right? Okay, and if we graph this, negative 1, positive 15, don't we just get this? Everybody agree? Okay. And so if I write this using interval notation, what's that going to give me, Sarah Lynn? What am I going to get for this interval? Okay. Okay. What goes in the middle? Well, hold on. So we got to have the union. That's the U when we're using interval notation. How do you remember? U is curved, parentheses are curved, right? Other side. Beautiful. Okay. Thumbs? Good. Okay. All right, so let's practice. For the end of the day here, let's practice. Get out a piece of scratch paper. I want you to write down what each of these are. I want you to write down what's the pattern there. So now here's how you remember these, right? What does U represent? U represents everything in the absolute value bars. It could be 2x minus 3, or it could, who knows, right? And A represents the number on the other side. So what does that become? What does that split into? What's the pattern? Well, we know this one, right? This is just kind of a warm-up. That one just splits into either U equals A or U equals negative A, right? Okay. Try the middle one. What's that split into? The absolute value of some expression, call it U, is greater than A. And again, U just represents everything inside. Okay, that's going out, isn't it? So what's that going to be, Mason? U is, what's that split into? You're right. Yeah, but so what's that going to split into? What or inequality? U is what? You know what you're doing. U is either, I'll get you started. U is either going to be greater than A or less than negative A. There you go. See what I'm saying? That's what I'm looking for, is the pattern. Okay, so how about this last one? Absolute value of U, where U is less than A. And or, everybody. And, okay, what's that going to look like? Maddie, what's that going to look like? U is what? Grammar, doesn't it? U is negative A and less than A. Okay, that's going to give us the 3-part one where the U goes in the middle, right? Okay, good. Think you got it? Okay, let's try it again. New piece of paper. New piece of paper and try it again. Or just flip it over or something. Just flip it over. Get a little more practice. Or just go someplace else, but don't look. Do it again. We're just memorizing is all we're doing. There you go. So try writing those three down in order real quickly. And then I'm going to let you work. You got 2 minutes. What's the pattern for the first one? It's like these. We're just doing flashcards. And we're just practicing, memorizing a little bit. Just try it. Write it down. Write it down. Okay, what did we get? Shane, what did you get for the first one? U is greater than A or less than negative A. Yeah, everybody buy that? In either order, it doesn't matter. You could do U is less than negative A first if you want to, or statements you can mix up. Okay, middle one. The isolated absolute value is less than some number A. Madeline, what'd you get for that one? Say it again. Not sure. Okay, let's see. Anson, what'd you get? Okay, so the U goes in the middle, right? Remember how we'd say that? We start in the middle. You're right. We'd say U is greater than negative A and less than A, right? Okay. And then finally, what's this one, everybody? U equals A or U equals negative A. Okay, good. That's a good start for today. I'll let you work the rest period.